This short video is going to illustrate some features of our gradient vector. Particularly as we move around, we can see how the gradient is changing relative to these lines of constant altitude. You can see up in the corner here we have our surface. So on the sort of greenish section here, we're looking at a peak. On the reddish section of level curves, we're looking at a valley, which is why the gradient points in the direction that it does. As I'm here over on the top part of this curve, you can see that the gradient points upward towards the top of our peak here. And that's, again, characteristic of the fact that the gradient is looking for the rate of maximum increase. As I move to the valley, you can see that the gradient now points outward from that valley, again looking for that rate of greatest increase. And again, that's what the gradient itself gives you as a vector. One of the other features of the gradient that we can grab out of this is that as I move around from location to location, one particular characteristic is that the gradient vector itself is always perpendicular or normal to the line of constant height here. So you can observe that at various locations as we move around, that in every case that gradient is perpendicular to the level curve. The other thing that we can grab out of this is that as the level curves pack a little tighter, you can see the gradient is larger, and where we have level curves that are farther apart from each other, the gradient is less. And this makes sense. Places where we have a lot of change happening over a short period of time, the altitude is growing rapidly, would be steeper, and we would have a larger gradient there. And places where we have those lines farther apart are indicated by places where the surface is a little flatter, and therefore the gradient is not as large. So those are a couple of features just out of the gradient itself. The other thing we could look at is how the gradient works alongside a unit vector. So now we can relate this a little bit to our directional derivative by putting on this unit direction vector and the projection. The projection that we see is this dotted vector as I move this around. And what that represents is our directional derivative. So what we are supposed to gather out of this is that the directional derivative has its largest value when we move in the direction of the gradient. So here again, as we move around, we can see that component changing as we move around. Again, there's the maximum, and everywhere away from that, as I take my derivative in other directions and I look at the rate of change, it's all just a portion of that gradient. And that is what the directional derivative is. It's a portion of the overall gradient when we move in some other direction or look in some other direction relative to the gradient itself. Again, noting that the gradient is the maximum and that every other direction from that is a smaller bit.